To do any mathematical calculations, or even to write any conditional statement, or even if you want to write a program that allows you to calculate anything, we need operators in our program. Just like how operators are necessary in mathematics, similarly operators are necessary in Python as well, or in any programming languages. That's why in today's module we will be discussing about operators in Python. In this module we will be discussing about all the different kinds of operators that are there in Python. Before that, if you want to become a successful data analyst or want to become a Python developer, and if you want to learn from our industry experts, then you can call on the given number or fill the form provided in our description. Not just that, with our every batch you will be getting 2 demo classes for free. So let's get started, guys. In our today's session, we will be talking about operators and operands. Operators are nothing. Operators are the actions that needs to be performed, and operands are the ones on which this action will be performed. Let's understand with the help of a simple example. Here we have x plus y is equals to 0. Now here x, y and 0 are the operands, and plus and is equals to is the operator over here. So operands are the ones on which the action needs to be performed. So on x, y and 0 the action needs to be performed, and what action is performing over here? The plus and is equals to action is being performed over here. That's why plus and is equals to here are operators, and x, y and 0 are our operands. So guys, this was about operators and operands. Operators are then further categorized into 7 new categories. What are these 7 categories that we have over here? Are arithmetic operators, we have comparison operators, we have logical operators, we have assignment operators, identity operators, membership operators, and bitwise operators. These are the 7 types of operators that we will be learning throughout this module. We will be learning each operator in detail in each session. Operators, as the term itself tells us, that these kinds of operators will be helping us to do the mathematical operations. Arithmetic operators are the operators that helps us to do the mathematical operations. Let's see some of the arithmetic operators that we have over here. We have addition, we have subtraction, multiplication, division, floor division, exponent, and we have modulus. So we'll be talking about each of them one by one. Let's get started. So guys, for taking the examples, I'll be considering 2 variables over here. I'm creating a variable 1 whose value is 12 and a variable b whose value is, let's say, 34. Okay. Now first of all, talking about our addition operator. Addition operator will simply provide us with the addition of the 2 numbers. Let's see how it can be done. I can create another variable over here called as sum. Sum is equals to addition of a plus b. So I'm taking a variable. I'm using the plus operator over here. I'm writing the b. And if I print it in the next line, print sum. Let's run and see what happens. When I run it, I get the output 46. That is the addition of both the 2 numbers which are there in our a and b. Similarly, talking about subtraction. For talking about subtraction, I'll be just switching the values. So guys, I'm creating a variable over here. Let's say z. Z is equals to, what I'm going to do, I'm going to subtract b from a. So I'll be writing a minus b. Let's print and see what happens. So I'm going to write print z. Once we run it, we get the output that 34 minus 12 is 22. Similarly, we will be talking about our division and the multiplication operator. For the multiplication operator, all I need to do is, instead of putting a minus sign over here, I'll use a multiplication. Multiplication here, in Python, we don't use x as a multiplication symbol. We use this asterisk symbol as a multiplication. So a star b, or you can call it a asterisk b. And as soon as I run it, it gives me the output 408, which is the multiplication of both the numbers. Talking about division, for division all you need to do is put a slash over here, not a backslash, just a normal simple slash. And as soon as you'll put a slash over here, you'll get the output as 2.8333 and so on. So this was our division operator. Now talking about our special new operators that we have. First of all, let's talk about exponent. What exponent do? Exponent helps us to find a number with the powers. When you write 10 raised to the power 2 or 2 raised to the power 45 or any number raised to the power anything, that time we use exponents over here. So basically, if you want to find the square or cubes or maybe a number with more powers, then what you can do, you can use our exponent symbol over here. Let's see how it can be done. So I'm considering a case where a is equals to 2 and I'll be writing b is equals to 5. So what I need to do, I need to write 2 raised to the power 5. So 2 raised to the power 5 means 2. For the exponent symbol, all we need to do is we need to put 2 asterisk symbols, that is 2 star sign, and whatever the number I want as a power of it, I'll be writing that. So 2 power 5. Now we will be considering the cases of variable, that a star star b. A 2 asterisk and b over here. Let's run and see what happens. It gives me 32, that 2 raised to the power 5 is 32. Similarly, next we will be considering the case of modulus. Now what is modulus over here? Modulus gives us a remainder of a number. When a number is divided by another number, whatever the remainder comes, that is what modulus gives us. Now modulus doesn't give us the value in decimal, it gives us a round of values. So let's have a look on how it works. So I'm considering a case over here where my a is equals to 5 and b is equals to 2. Now for using a modulus symbol, all you need to do is, you need to write shift plus 5, that is your modulus symbol. This is also known as a percentage symbol. We use it as a percentage, and here it is also called as modulus. So once I run it, it gives me the output 1. Why it gives me the output 1? Let's have a look. Let's have a small look. So why it gives me 1? I'll explain you that. So I'm considering 5 as a number over here, and when divided by 2, 2 times 2 is 4 and the remainder is 1. That's why the modulus of 5 modulus 2 gives us 1. Similarly, let's consider another case. I'll be writing 8 and here I'll be writing 3. So 3 2 times is 6 and the remainder is 2. So when we will write 8 when divided by 3, it gives us the remainder 2. Let's have a look if it works or not. So if I'm considering a is equals to 8 over here and b is equals to 3 over here and I run it, yes, it gives me 2. So this is how it works. It gives us, the modulus basically gives us the remainder once we divide a number by another number, right? Next thing that we will be talking about is our floor division. Now floor division is pretty much similar to division, but only there is one major difference, that when you do a floor division, it gives you the round of value to the previous integer, not the next integer that is going to come up, the previous integer. Suppose even if you have a round of value of 2.8, even it will still give you 2, not 3. Okay. So let's have a look on how it can be done. I'm considering the similar example, that 8 when divided by 3. So if I use a simple division operator over here, so it gives me the output 2.66, and at the same time if I consider a case of floor division, for floor division all you need to do is you put 2 slashes at the same time, 0.66. Now let's see what happens when we do it with the floor division. With the floor division we got 2 over here. So basically division and floor division are almost similar, where division gives you the whole value with the decimals, the floor division gives you the value, the round off value to the previous integer. Whatever the integer we have over here, even if it was 2.666, it will still give you 2. It will eliminate all the part after the decimal. This is how our floor division works. So these are the 7 arithmetic operators that we have discussed in this module. 6 types of comparison operators in Python. First is greater than, second is smaller than, third is greater than and equal to, fourth is smaller than and equal to, fifth is equal to, and sixth is not equal to. So we will be discussing each of them one by one. So guys, here we will be considering 2 cases. Let's say I have an example over here. A is equals to 12 and B is equals to 3. Okay. Now first of all, let's consider the case of greater than. So print A is greater than B. Let's run and see what output it gives us. It gives us true that yes, A is greater than B. Similarly, if we consider the case of smaller than, if I print A is smaller than B, it gives me false because A is a 12 and 12 is not smaller than C. That's why it gives me false. Talking about our third scenario, we have greater than and equal to. So A is greater than and equal to. In this case, suppose if I change the condition over here, that in both the variables I will write 12, and if I run it, it gives me true. Why? Because A is greater than and equal to 2. Now greater than and equal to means it also counts the values which are greater than 12 and including the 12 itself. When we were using only greater than 12, it will not count 12 in that condition, but at the same time if we consider the case of greater than and equal to 12, it will also count the 12 over here. That means that the number is, if the number is equivalent to the other number or greater than the other number. Similarly, smaller than also works like this. So if we write A is smaller than and equal to 12, it again gives us true. I'm putting it back to 3 now. Talking about equal to and not equal to. Now, next two operators that we have are equal to and not equal to. Let's first consider the case of equal to. If I want to check that the value inside A is equal to the value inside B, all I need to do is I write A double equal B. Here we are not assigning A the value B, we are saying that the value inside A is equal to the value inside B. If it is yes, it will give us true. If it is false, if it is a no, then it will give us false. So if I run it, then we can clearly see that in both the variables we have 12, that the values of both the variables are 12. That's why it gives us true. At the same time, if I would have written 13 over here and would have run it, it would have given me false because the values are not similar. Here we are not talking about the data types, the both has integer. We are talking about the values over here. That here we have 12, at the other side we have 13. So 12 and 13 are not equal to each other. Similarly, we will be using our not equal sign. For not equal sign, all you need to do is put an exclamation mark followed by equal to sign. So we will be checking if A is not equal to B. So yes, A is not equal to B. That's why it's giving us true. As we can clearly see that the A's value is 12 and the B's value is 13 and they are not equal to each other. Here that is AND, OR and NOT. AND operator gives us true if both the conditions that we have given are satisfied. Whatever two conditions that we have given, if they are satisfied, it gives us true. Okay. Second is we have OR operator. OR gives us true if either one of the operands is true. Whatever conditions that we have provided, if any one of them condition also satisfied, then too it will give us true. Third is NOT. NOT gives us the reverse of both of these operators. So if AND is giving us true and we have used NOT with it, then it will give us false. Similarly, if OR is giving us false, but at the same time if we have used NOT with it, then it will give us true. This is what AND, OR and NOT do. So let's understand it with the help of an example over here. So first of all, we will be talking about AND operators. I'll be considering a case of a variable A is equals to 25. So I'll be printing over here that A should be greater than, let's say, 12 and A should be smaller than 35. Now let's run and see what happens. It gives us true. Why? Because here A is satisfying both the conditions, that A is also greater than 12 and at the same time A is also smaller than 35. Let's consider a case where A is not satisfying any one of the conditions. So let's take an example that I am writing 45 over here. So 45 here is satisfying that A should be greater than 12, but it is not satisfying that A should be smaller than 35. So let's run and see. It gives us false. So if only one of the condition is satisfied, then too it will give us false. So AND will only give us true if it satisfies both the conditions. Now let's consider a case of OR operator. For OR, again I am using 25 as a variable. So I'm gonna print over here that A should be greater than 12, and because we are using OR operator, I will use a OR in between, that A should be smaller than 14. Now what is happening over here, the A is satisfying only one of the condition, that A is greater than 12. A is not smaller than 14, but it is greater than 12. So this was our OR operator, where even if one of the condition is also satisfied, it gives us true. Now let's talk about our NOT operator. So here again I am taking an example, A is equals to 25. So I'm gonna print NOT. And here I will be using our AND condition, because what NOT does, it reverses the output for AND and reverses the output for OR. So let's see, I'm writing A is greater than 12 and A is smaller than 35. Yes, it is satisfying both the condition, not considering the NOT part, but this part is satisfying both the conditions. So according to AND, it should give us true. But because we have used NOT over here, that means it will give us false. Right? If at the same time I would have written over here 26, that A should be greater than 26 and A should be smaller than 35, it would have given me true, because it is not satisfying. AND means that it should satisfy both the conditions. So it is not satisfying both the condition, it would have given false for only AND part of it. But because we have used NOT over here, it is giving us true. Discussing about the assignment operators. So here assignment operators are used in Python to assign a value to a variable. For example, if I have written A is equals to 6, so A's value is 6. I'm assigning that 6 value to A. So that is called as assignment operator. So that is equal to over there is called as assignment operator. Now there are four types of operators over here that we have. First one is equals to, second is plus is equals to, third one is minus is equals to, and fourth one is multiply is equals to. So we guys clearly know that what is equals to over here. Like for example, if we have written x is equals to 6 over here, then that means we have assigned this 6 value to our x. Now let's talk about what is plus is equals to. So guys, let's take an example over here. Let's say you are playing a game and there is a score. There is a variable called as score. Okay, and we have this thing inside the game that every time we touch a coin, our score increases by 2 points. So what we will do, guys, let's say our score is initially 0 and we want to increment it every time it touches the coin. So what we will be writing? We will be writing score is equals to score plus 2. That means every time it touches the coin, the score increases by 2. Now there is one way of writing this. Okay, then there is our assignment operator plus is equals to, where we don't have to write it over and over again. All we can do is write score plus is equals to 2. These both things are the same. What this thing will do, what this equation will do, the second equation will do the same thing over here. So when we write score is equals to score plus 2, all we can do over here is we can write score plus is equals to 2. Similarly, if we have minus, suppose we touched an obstacle, we write it in this way that score is equals to score minus 2, right? So instead of writing score is equals to score minus 2, that means instead of decreasing it in this way, all you can do is you can write score minus is equals to 2. So it will do the same thing what this one is doing, but what it will do, it will just reduce your time. You can use a shorter statement instead of writing score is equals to score minus 2. Similarly, we have multiplication is equals to operator, where every time let's say you have touched a life or you have touched anything that comes once or twice in a game and your score gets multiplied by 2. Suppose your score is 100 right now, it gets multiplied by 2, it becomes 200 by touching that particular one thing. So in that case, what you instead of writing score is equals to score times 2, all you can do is you can write score multiply is equals to 2. So again here it will do the same thing that the first statement is doing, just it's a short method. So guys, these are our four assignment operators. First is equal to, second is plus is equal to, third is minus is equals to, and fourth one is multiplication is equal to. We will be talking about identity operators. Items we have provided, it compares it and checks if they are from the same object type or if they have a same memory address. There are two types of identity operators that we have over here, that is and is not. Let's have a look on how it can be used in Python. So guys, to understand identity operators, I'm considering an example over here where I'm creating one variable a is equals to 1 to 3 inside a string, while at the same time I'm considering a b variable which is equals to 4, 5, 6. Now we clearly know that first one is a string and the second one is an integer. If I'll write over here that print a is b, that A's data type is similar to B's data type. If it is same, it will give us true. If it is not same, it will give us false. Let's run and see. It is giving us false. Why? Because we clearly can see over here that A is a string and B is an integer, right? At the same time, if I write B is not, A is not B, which is true, right? Because A is a string and B is an integer. So A's data type is not similar to B's data type. So that's why it gives us with true. So this is how our two identity operators is and is not can be used. We will be discussing about it thoroughly in our problem solving session. About bitwise operators. If you want to become a successful data analyst or want to become a Python developer, and if you want to learn from our industry experts, then you can call on the given number or fill the form provided in our description. Not just that, with our every batch you will be getting 2 demo classes for free. So let's get started, guys. With the binary numbers, they allow us to compare the binary numbers basically. So there are 5 types of bitwise operator that we will be discussing about in this whole session. Our first is AND operator, second is OR operator, third is XOR operator, fourth one is zero fill left shift operator, and fifth one is zero fill right shift operator. Now let's understand what is AND operator. AND operator works like the AND gate over here, which gives the binary result of 2 zeros as 0, 1 0 as 0, 101 as also 0, but when it's 1 1, when there is a 1 1 in a binary number, it gives us 1. Let's guys, first of all, let's understand binary numbers to understand this method over here. So guys, first of all, talking about binary numbers, we all know there are two binary numbers, 1 and 0, where 0 indicates off and 1 indicates on. Correct. To find a binary number of any decimal number, we have a very simple method. We have a very simple formula over here. We will see what this formula is. For example, we have a binary number 8 over here. What we will do, we will keep taking an LCM over here with 2. Why with 2? Because binary itself means 2. That's why every time we will be taking an LCM from 2. Okay. So I'll create a small table like this. 2 when 8 when divided by 2 gives us 4 and the remainder is 0. Again, I'll write 2 over here, that 4 when divided by 2 gives us the remainder 0, and here also we will be writing 2. Again, I'll be writing 2 over here. 2 when divided by 2 gives us the remainder 0 and gives us the output 1. So we have 0, 0, 0, 1 over here. This 1 will also come back to here. Now about binary number, that is one interesting thing, that we count the binary numbers from bottom to top. So we will not be writing 0, 0, 0, 1 as 8. This will be wrong. We will be writing 1, 0, 0, 0 is equals to 8. That means it goes from all the way downside to up. This is how we find a binary number of any number. So I'll be considering another example over here, that is 15. Again, I'll be creating this table. I'll be writing 2 over here. Okay, 7 times 2 is 14 and remainder is 1 over here. Again, I'll write 2 over here. 3 times 2 is 6 and the remainder is 1 over here. Again, I'll write 2 over here. Times 1, remainder is 1, and here we get the output as 1, 1, 1, 1, which is our 15. So the binary number for 15 would be 1, 1, 1, 1. Now this is a simple method of finding a binary number. But what if there is a huge number? For huge number, you guys don't have to struggle much. All you need to do is when you go to Python's PyCharm. So suppose if you want to find a binary of any number, let's say I'll be finding the binary of 15 over here again. All I need to do is print bin, short form for binary, and whose binary I want to find. I want to find 15's binary. So it will give me an output over here with the prefix added to it, that would be 0b. So 0b1111. So as we also calculated, it gave us 1111, and here also it is 1111. So if you want to find the binary of any number over here, let's say if I write it for 150, it gives me 0b 100101110. This is how by this method you can find a binary of any number. You don't have to struggle much. But now you know what is the method also and how you can do it on Python as well. Similarly, if you want to reverse it, like till now what we were doing, we were converting the decimal numbers to binary. Now what if we want to convert binary number to decimal? For that also we have a very simple method over here. Let's have a look. So here I'll be writing conversion of binary to decimal numbers. Okay, so converting binary to decimal number is very simple. We'll start with 1. 1 when multiplied by 2 gives us 2. 2 when multiplied by 2 gives us 4. Why I'm multiplying it by 2 every time? Because we are finding it for the binary number, and binary, the word binary itself means 2. So every time we will be multiplying it by 2. Next is 8. 8 times 2 is 16. 16 times 2 is 32. 30 times 2 is 64. Let's consider it till here. Now suppose we have any binary over here. Let's say I have a binary 1110. Okay, I have this binary. I want to convert it to decimal. All I need to do is I'll start putting this below them. So 0 goes over here, 1 comes over here, 1 comes over here, and 1 comes over here. So what I will be doing, I'll be writing 8 multiplied by 1 as 8 over here, 4 multiplied by 1 as 4 over here, 2 multiplied by 1 as 2 over here, and 1 multiplied by 0 as 0 over here. So 4 plus 8 plus 2 will give us 14. And this will be the 1110 will be our binary for 14. And if you want to check, you can go and check with the help of the bin method as well to what is the binary of 1110, and you will get the output over there like this. Okay. So this is how we can convert binary to decimals and decimals to binary as well, right? Now let's understand with the AND method that how AND method works over here in Bitwise operator. So how AND method works over here, that whenever there is a binary, let's take example, I have one binary over here, that is 1 0 1 0, that is the binary of number 10, and I am taking another binary over here, that is binary of 8, which will be 1 0 0. Okay, I know this already, but you can also find it with the help of the bin method as well. Now what I will be doing, I will be comparing it over here. So it says that 0 0 operation gives us a 0. It will give us a 0. 1 0 also gives us a 0. It says 0 0 again gives us a 0, and 1 1 gives us a 1. So when we will apply the AND method on these two binary strings, it will give us 1 0 0, which is the binary number of 8. Let's see with the help of the example in Python as well. So I'm considering a case of two variables over here. A is equals to 10 and B is equals to 8. Now what I will be doing, I will be performing this AND operation over here. So for that, for writing AND, all you need to do is put an ampersand between A and B. So if I print A ampersand B, let's run and see what we get. We get 8 over here, and if you want to see it in the format of a binary, like if you want to understand in the format of binary, we did it in our so as expected, we get 8 over here, which is correct, that when we will apply the function of AND on the binaries of A and B, we will receive 8 over here. Okay, now let's move ahead to our next operator, that is OR operator. Let's see what OR operator does. So guys, here our OR operator says that OR operator is represented by a straight line over here. Okay. Now here our OR operator says that whenever there is a 0 and 0, it gives us 0. Whenever there is 1 and 0, it gives us 1. Whenever there is 0 and 1, it also gives us 1. And whenever there is 1 and 1, it also gives us 1. So only in the condition of 0 and 0, it gives us 0, but otherwise in all the other condition, it gives us 1. Let's solve a small problem related to this. I'm considering the same example over here. Let's say I'll be writing 1 0 1 0, which is the binary of 10, and I'll be writing 1 triple 0 over here, which is the binary of our number 8. So now if we'll apply the OR operation on this, so 0 0 will give us 0, as we have seen in the first line. 1 0 will give us 1. 0 0 again will give us 0, and 1 1 will give us 1. So when we apply an OR operator on the binaries of 10 and 8, we will receive 10. Let's have a look. Let's solve it in Python and let's see how it can be done. So here guys, I'm considering the same examples, that A is equals to 10, B is equals to 8. And for applying the OR operator over here, all I need to do is put a straight line in between of A and B. And if I run it, it gives us 10. So that means the method that we have learned, that is correct. And this is how it works, that when there is a binary of 10 and binary of 8, when we apply OR method to it, it will give us 10 in return. Moving to our next operator that we have in Bitwise, that is our XOR operator. Let's see how the XOR table looks like. So here our XOR operator is represented by an upward arrow. And how an XOR operator works on our binaries, let's see. So whenever there is a 0 and 0, it gives us 0. Whenever there is 1 and 0, it gives us 1. Whenever there is a 0 and 1, that means whenever there are opposites, it gives us again 1. It doesn't matter if 1 is coming first or 0 is coming first. Whenever there are opposites, it gives us 1. And whenever there is a similar numbers, XOR gives us 0. So even if it is 1 and 1 over here, it still gives us 0. So applying the same method on 10 and 8, let's see what happens. So if I write 1 0 1 0 over here and 1 triple 0 over here, 0 0, so they are same, that's why it gives us 0. 1 0 gives us 1. 0 0 again gives us 0, and 1 1 gives us again 0. So it should give us 2 over here. 0 0 1 0 will be for 2. So it should give us our decimal number 2 over here. Let's try it on Python and let's see if our method is correct or not. So I'm considering the same example over here, where A is equals to 10 and B is equals to 8. So if I apply the XOR method over here, I write A XOR B and run the program. So let's see what output we get. Yes, we get 2 over here. That means the method that we have learned is correct and it works in this way. Right guys, so this is how AND, OR and XOR works in a bitwise operators. Now we will be talking about bitwise left shift operator. Now let's understand what is left shift operator. So to understand our left shift operator over here, I'll be considering an example where our A is equals to 10, whose binary is 1010. Okay. Now what I need to do is, if I use a left shift operator, it will add two more zeros to it. The left shift operator shifts the whole value by two zeros by adding two zeros in the end. So you can add as many zeros as you want, doesn't matter how many times. Like if you're shifting it with two zeros, it will shift by two zeros. If you're shifting it with one zeros, you can shift it by 10. The choice is totally up to you. That it just shifts from the left hand side. From the left hand side, it gives a shift over there. So if I use a left shift operator and shift it by two zeros, so let's see what will I get. I'll get 1010 and if I put it over here, I'll write 000 101. So my 32 plus 8 will become 40. So this should give us 40. Let's give it a try on our Python as well. So I'm considering an example of A is equals to 10 over here, and then I write print 10 left shift 2 and run it. It gives me 40. That means our left shift bitwise operator is working clearly, and this is the method to shift it. Let's consider another example over here. So I'm considering an example of 15 over here. We know that 15 is equals to 1111. If I'll shift it by 1 over here, let's see what do we get. We get 11110. When I get 0 1 1 1 1 over here, 16 plus 4 is 20, 20 plus 8 is 28, plus 2 is 30. So it should give me 30. By shifting it with 1 0, it should give me 30. Let's see if it works or not. So when I write A is equals to 15 over here, and I shift 15 by 1 0, then yes, I get the output 30. That means it is working properly, and this is how the method of left shift operator works. Now let's understand what is right shift bitwise operator. So guys, talking about right shift bitwise operator, so what right shift does, right shift removes the last two bits from the string. Let's have a look on how it can be done. For example, I'm considering the case of 15 over here. So if I use a right shift bitwise to it, so it will be 15. For the right shift, I will be using the arrows that are pointing towards the right, and I'll be writing the value that by how many bits I want to shift it, how many bits I basically want to remove from the end. So from 1111, if we remove the two bits from it, we are left with 11. So if I write 1 1 over here, I get 3. So if we apply the right shift bitwise operator on 15, the value that we will receive will be 3. Let's have a look on how it can be done. So here I have created a variable A whose value is 15. I'll be applying the right shift operator over here. So 15, arrows pointing towards right. I'll be shifting it by two values. Let's run and see what output do I get. I get 3 over here, which is correct. That our method that we have applied to learn right shift operator is correct. Let's consider another example over here. So let's say I have taken a binary string for number 8, that is 1000. What I want to do, I want to shift it by 1. I want to remove 1 0 from the end. So I'll be using a right shift operator on it. So what I will be doing, I'll be using 8 right shift by 1, because I want to remove one bit from the end. I'll be using right shift symbol over here and using 1 over here. So if I remove 1, it gives me 100, which gives me 4. So if I remove one bit from the end of the 8, I'll receive 4. Let's have a look how it can be done on Python. So here I'm considering the case of 8 over here, that A is equals to 8. And here we will be removing one bit from it. And here we will be removing one bit from it. So I'll be writing 8. Right shift bitwise operator, and I'll be shifting it by one value. That means I'll be destroying one value, and if I run it, it gives me 4. So this is how, guys, the right shift and the left shift operators are used in bitwise operators. learning about membership operators. Now guys, what is membership operators? Let's understand that. Membership operators allows us to check for a sequence in an object. There are two types of membership operators that we have. We have in and not in. Let's have a look on how they can be used in our programs. So guys, to explain membership operators, I'm considering a case where I'm taking a variable a. Inside it, I'm adding a string hello. Now what I need to check, I want to check if alphabet a is present inside the string a or not. For that, all I need to do is I'll write print. Inside the string, I'll write a, that a in our variable a. So let's run and see what happens. If I run it, it gives us false. Why it gives us false? Because we can clearly see that in the word hello, we don't have alphabet A. At the same time, if I would have written O over here and would have run it, it would have given me true. Why? Because yes, O is present inside A. Now considering the case of not in over here, I'm taking the same example. Here I will be checking O not in. That means if it is not there inside A. Simple English syntax is here that O not in A. That means O is not there in A. If it is not there in A, it will give us true. If it is there in A, it will give us false. So yes, O is not there in A, so it gives us false. At the same time, I would have written A. A would have given me true. Why it would have given me true? Because A is not there in our variable A. So this is how our membership operators work, where we check if a sequence is present in an object or not. So I hope guys membership operators are now clear to you. So here we have completed 7 operators in this module. I hope you have no doubts and questions. So stay connected and I'll see you in the next session. Thank you.